Find the partial fraction decomposition for 7x squared plus 5x plus 12 all over 4x cubed minus 8x squared plus 9x minus 18. The first step here is to factor the denominator. I'm going to pull that off to the side. So 4x cubed minus 8x squared plus 9x minus 18 can be factored using grouping. So from the first two terms, I can factor out a 4x squared, and I would be left with an x minus 2. From the second two terms, I can factor out a 9, and I'd be left with x minus 2. Now, we have two terms, and what they have in common is a factor of x minus 2. So I'm going to factor out that x minus 2, and I would be left with a 4x squared from the first term and a plus 9 from the second term. So what we have here is that the original rational expression is 7x squared plus 5x plus 12 all over x minus 2 times 4x squared plus 9. And 4x squared plus 9 can't be factored any further. It's the sum of squares. So what we have here is what we call a distinct linear factor and an irreducible quadratic. So when we go to create our partial fractions, above our linear factor, x minus 2, is going to go a generic constant that we're going to need to solve for. And our second partial fraction will have the irreducible quadratic, 4x squared plus 9. And what goes above a irreducible quadratic is a generic linear function. So a generic linear function is of the form bx plus c. So we're going to need to find the slope and the constant in that linear piece. So we need to find the values of a, b, and c to find our partial fraction decomposition. But once again, the idea is that when you combine these two back together, we should get back to the original expression. So we're going to do that. Let's go ahead and combine these back together. So the common denominator is these two multiplied together. So I'll have to multiply the left side by 4x squared plus 9 on the top and on the bottom. And on the right side, I'll have to multiply by x minus 2 on the top and on the bottom. And then I'll be able to put these together as one rational expression again, so they have the same denominator. So they're going to come together as a times the quantity 4x squared plus 9 plus b, x plus c, all in parentheses, times the quantity x minus 2 over that common denominator. Okay, so now, in order for these two to be equal, they have the same denominator, one's in factored form, one isn't, but in order for these to be equal, their numerators are going to have to be equal. So we're going to have our equation that we're working with. We're going to have 7x squared. So we're going to have that 7x squared plus 5x plus 12 is going to have to equal a times 4x squared plus 9 plus the quantity bx plus c times the quantity x minus 2. So this is the equation that we're going to work with to find the values of a, b, and c. Now on this one, we're going to use a combination of the two techniques. So we are going to start by letting x equal 2 because that will zero out an entire term. So if I let x equal 2, then on the left hand side, I'm going to have 2 squared is 4, 4 times 7 is 28, plus 2 times 5 is 10, plus 12 is equal to, again, this second term zeroes out, so we're just plugging 2 in here. So 2 squared is 4, 4 times 4 is 16, and then 16 plus 9 is 25. So I have 25a. This left side works out nicely. 28 plus 10 is 38, plus 12 is 50. So we get 50 is equal to 25a. So we get a is equal to 2 if we divide both sides by 25. So that allowed us to solve for the value of a, but there is not a real number solution to zero out 4x squared plus 9. So what I'm going to do from here is I'm going to set up a system of equations. So I was able to at least find one of our 3 missing values, and now solving a system of equations with one known value will make our life a little bit easier. So let's look at what the system of equations would be. So I am going to go ahead and distribute in the a and then distribute out this right-hand side. It's not totally necessary to do, but I'm going to go ahead and do it. So I have 4a x squared plus 9a. So I'm distributing in the a. And then over here, I'd have to multiply it all out. So bx times x is bx squared plus bx squared plus, so if I do first and then outer, minus 2 bx, and then plus cx minus 2c. Okay, so now I'm looking at this original left side and then this distributed out right side here. And I'm trying to create a system where I focus on, okay, what's in front of x squared on the left side of the equation, and then what's in front of x squared on the right side of the equation. So over here, I'm going to have the first part of my system, 7 is equal to 4a plus b. So that's everything in front of x squared, right? So that's like x squared in quotes, just to help keep me a little organized. Now what's everything in front of x? So what's in front of x over here is a 5. What's in front of x on the right side is negative 2b plus c. So what's in front of my, quote, x terms? I have 5 is equal to negative 2b plus c. And then what are my constant pieces on the left and right? So on the left, it's just 12. That has to equal 9a minus 2c. So my constant stuff, all right, so I'll put constants. That's going to be 12 is equal to 9a minus 2c. So here is my system of 3 equations and 3 unknowns. But I don't have 3 unknowns. I was able to find a is equal to 2. So now I can substitute 2 into a and solve for b on this top equation. So what are we going to get? 7 is equal to 4 times 2 plus b. 4 times 2 is 8. If I subtract the 8 to the other side, I get b is equal to negative 1. And then I can substitute 2 into this bottom equation to solve for c. So I'd get 12 is equal to 9 times 2 minus 2c. So 9 times 2 is 18. If I subtract 18 from 12, I'm going to get negative 6 equals negative 2c. Divide by negative 2, I get c is equal to 3. So I get my values of a, b, and c, but we're not done until we plug them back into our partial fractions. So if we remember, we had partial fractions that was a above x minus 2, and then we had bx plus c above 4x squared plus 9. So a was 2, so we'll go ahead and plug 2 in. B is negative 1, and c is 3. So we'll put a negative x and then plus 3. So this is my partial fraction decomposition. One quick note before we end this is to say that, again, we didn't necessarily have to distribute everything out. If we can do a little bit of mental math to recognize what's going to be in front of the x squareds over here, well, 4a would be, and then here, bx times x is x squared, so b will also be in front of x squared, so 4a plus b. Whatever mental math we can do on the algebra or arithmetic on these problems, we want to go ahead and do.